So in this example, we are asked to differentiate the vector-valued function. And we have this beautiful function vector r of t, with its 3 components. So I'm going to label these components to start. We have our f of t component, we have the g of t component, and we have the h of t component. So keeping in mind that we can differentiate component by component, to get us started here, let's differentiate each piece. And of course, if you're comfortable, by all means, go right for it. So I'm going to start here by differentiating each component separately, and then we'll put it all back together at the end. So differentiate each component of your vector-valued function. So our first component, we have f of t is defined here as 6t multiplied by the natural exponential raised to the minus t. So we're going to differentiate both sides here with respect to t. So taking the d dt of both sides of this component, what I'm going to do is actually keep that scalar multiple 6 on the outside of my differentiation, since it's just a constant multiple. So this is going to be 6 multiplied by the derivative of t times the natural exponential raised to the minus t. So what is this leaving us with? We have f prime of t is going to be equal to 6 multiplied by the derivative of t times the natural exponential raised to a negative t. So we're going to need a product rule. A scalar valued function product rule. So here we go. This is going to be 1 multiplied by the natural exponential raised to the minus t plus t multiplied by the derivative of the natural exponential. So that's minus 1 times the natural exponential raised to the negative t. And look at this, we have a greatest common factor here of the natural exponential raised to the minus t. So this is going to leave us with 6 times the natural exponential raised to the minus t multiplied by 1 minus t. So there is our first component, or the derivative of our first component. That's f prime of t. So now let's go ahead and differentiate our g component. So here we have g of t is defined as 9 multiplied by the natural logarithm of 1 minus 2t. And again, here we are taking the derivative of both sides of this expression with respect to our arbitrary parameter t. And again, we've got a scalar multiple here, 9. So I'm going to keep that 9 on the outside of my derivative. So we have 9 multiplied by the derivative of the natural logarithm of 1 minus 2t. So here we go, g prime of t is equal to 9 multiplied by, so with a natural logarithm, don't forget it's the derivative of the inside, or the argument, which is negative 2, all over the original argument, which is 1 minus 2t. And of course, we want to simplify. This leaves us with negative 18, all divided by 1 minus 2t. So there is the derivative of the second component, g prime of t. And we're ready for our last part. We want to differentiate, and let's actually write this down before we give ourselves more room. We have h of t is defined here as t multiplied by cosine of 2t. So now giving ourselves plenty of room. Just as we did with the first two components, we are differentiating both sides of this with respect to our parameter t. And so here we have t multiplied by cosine of 2t, so we're going to need to apply the product rule. So we'll be left with h prime of t is equal to, the derivative of t is 1 multiplied by cosine of 2t plus the original t multiplied by the derivative of cosine. So this is going to be negative sine of 2t multiplied by the derivative of your argument, which is 2. So So we have no greatest common factors here, and we can just rewrite this to make it look a little nicer. We're left with cosine of 2t minus 2t multiplied by sine of 2t. And we have the derivative of each component, and we're ready to state our beautiful final answer. So we can say that therefore vector r prime, our tangent vector, is the derivative of the f component, the derivative of your g component, and the derivative of the h component. Plugging in everything that we just found, we are left with 6 times the natural exponential raised to the minus t multiplied by 1 minus t. We have negative 18 all divided by 1 minus 2t. And last but not least, we have cosine of 2t minus 2t times sine of 2t. And so this is our beautiful final answer.